For this next problem, 7a, we're asked to find one positive angle and one negative angle in radians that are coterminal with the given angle, meaning they stop at the same place. Terminal meaning end or stop, like a bus terminal or a train terminal. It's the end of the line, it stops. So we have 5 pi over 4. To make it land in the same spot, we know that we have, for instance, let's pick, we have the unit circle. This is 0 pi, but it's also 2 pi and 4 pi, etc. It keeps going if we add 2 pi. So if we add and subtract 2 pi, we will be guaranteed to be coterminal. Now we're not guaranteed to be one positive and one negative, and we'll see that in problem B. But for this one, we have 5 pi over 4, and 2 pi, if we change it to fourths, 8 over 4, so 8 pi over 4 is the same thing as 2 pi, and if we add and subtract that, we end up with 5 plus 8 is 13 pi over 4. That's coterminal with 5 pi over 4. And if we subtract 5 minus 8 pi over 4 equals negative 3 pi over 4. So all of these are equivalent to each other and to the initial 5 pi over 4. There's an infinite number of coterminal angles with that. Let's look at the next problem. This one's a bit tougher. It's going to be easy to get a negative. Let's add 2 pi. But when we add 2 pi, it would be 4 pi over 2. 4 divided by 2 is 2. And that's going to give us a nice negative 7 pi over 2. But to get a positive coterminal, we're going to need to add a lot. That's 5.5. We're going to need to add, looks like 6 pi. So let's change the color here. And let's put negative 11 pi over 2 plus 6 is 12 pi over 2. 6 pi over 2 equals pi over 2. So we had to add a lot of rotations, 2 pi, 4 pi, 6 pi. We decided to add 6 pi, and that's how we got a positive coterminal. So to conclude that problem, negative 11 over 2, negative 11 pi over 2 equals negative 7 pi over 2 equals pi over 2. They're all coterminal.